Okay, well, the next speaker is myself. So, hi. I'm Stefan Kreber. I work at Canonical on containers. I'm the LXC and LXD project leader. And today I'm going to be going through a year of upstream development on LXD. And it's been a busy year. So, just briefly, in case someone doesn't know what LXD is. LXD is a container manager, but it's a system container manager. So we don't really run your usual Docker type workload. We do run an entire operating system. So think of it more like a virtual machine. It's designed to be very simple, both on the CLI and our API. We try to also make like terminology and everything reasonably clear. It's very fast. There's no VM or anything involved. It is very safe because we use just about every security feature you can think in a kernel, plus the ones we've implemented in the kernel. So that means all of our containers use the user namespace by default. They use seccomp, they use Palmer, they drop capabilities. Pretty much anything you can think of, we've got it. And it's very scalable. It works on a single laptop just fine. You can run multiple systems and then interact with them over the network. Or if you want to go even further, you can start and cluster them and then run like tens of thousands of containers against that. What LXD isn't, well, I kind of went through that already, but it's not a virtualization technology. We only use containers and namespaces in the kernel. So it runs on every architecture, it's very fast, runs inside VMs, it's containers, I mean, you know what that is. It is also not a fork of LXC. We are the same project, just LXC has been around for over a decade. It's written in C. It's a low-level C library to interact with the kernel with a set of tools. LXD is one level up. It uses LXC through a Go binding and drives it that way. It lets us, that way we could provide some of the more modern interactions and use Go to make things simpler for ourselves, while still keeping liblxc in C as the low-level interaction with the Linux kernel. Because for anyone who's been doing it in Go, interacting with namespaces from Go is not very fun. C works way better for that. And as I said, we don't really run application containers. If you want to run application containers, that's perfectly fine. You can run Docker inside a LXD container. We do nesting just fine. That works. Now, as for the actual part of my talk where we look through a year of containers, well, of LXD. So we kind of the highlights for this year. It was our second LTS release. For us, an LTS release means we tag something. So we did 2.0 2 years back. We did 3.0 this year. And then we will support it with bug fix and security only for 5 years. So LXD 3.0 has been released in April. It's a second LTS release. We've done 3 bug fix releases on top of it so far. We do backport most of our bug fixes onto that release, and we do have a 5 years commitment to bug fixes and security updates on that. We've also done 10 feature releases. We are effectively on a monthly release cadence for LXD. So we did miss 2, as you can tell. That was because well, it took us a while to do the 3.0. I mean, the LTS took us a little while. So we were hoping to be able to do the LTS on the side, but that didn't work out. So we ended up not releasing in, I think it was February and March that we skipped. And we've done, as I mentioned, 3 LTS bug fix releases. Now, there's another thing that's kind of exciting that happened this year. It was a bit of a surprise to some extent. Chromebooks. Well, all Chromebooks ship with LXD now. So our user base grew quite a bit thanks to that. That happened late September. It is advertised as cross-TINI or Linux apps on Chromebooks. When you use that feature, it kind of looks like that. The first time you use it, it installs Linux, which is always kind of funny considering you're already on a Linux machine, but anyway. And once you've done that, then you effectively can install apps. You get a terminal, you can play with the terminal, you can install packages inside it. But if you know how to get to it, you can also drop into LXD. And you can see that there's one container running, which is called Penguin. That's the default Debian container that runs on the Chromebooks. It's got a special set of libraries and hooks and pass-through set up so that it can reach your graphical server and can render very easily. There are some things that are still being worked on. Current work in progress on their side is USB pass-through, GPU pass-through, and sound. Those things will be coming. They are all supported by LXD. They're just not available right now on Chromebooks because out of an abundance of safety, the way those containers work on Chromebooks is actually by first running a virtual machine, and then inside a virtual machine running LXD with all your containers. So every user's got a virtual machine, and then you can have as many containers as you want inside there. Which makes things a bit trickier because while we can share a GPU very easily on the system directly, they first now need to share the GPU with the VM, which is pretty tricky, and then we can get it from inside the container. But it's coming. So here I can see I've been spawning a bunch of containers. What did I do? Like I did, a bunch of different distros to just show that you can use our normal images, you can run whatever containers you want on your Chromebook. It's all persistent, it all works well. It uses BurFS as its storage, so if you copy stuff, it uses subvolumes and it's reasonably quick. And as I mentioned, you even have GUI access. So in this case, what I did is I just, in the terminal that comes when you enable Linux apps on your Chromebook, I installed Frozen Bubble. And then you can just go into the app launcher on your Chromebook. Like you don't need to do it from the CLI or anything. You go into the app launcher, and alongside Chrome, Sheets, Slides, whatever you've got in there, you're going to see Frozen Bubble because it actually pulls the list of applications and packages that are installed in your container, and they show up in your launcher. You click on it, and it's spawned inside your container and shows up on your graphical server. So it's pretty neat integration. Really looking forward to seeing them land more complex integration. As I mentioned, GPU, USB, and sound are going to be pretty neat because people want to run Steam inside there. And so far it does, so long as the game is 2D and your CPU is beefy enough to run GL in software. But it's going to be much better once we get GPU pass-through on those Chromebooks. All right, so LXD itself. 3.0 was pretty busy. So kind of the highlights there. Clustering. We presented that last year at FOSDEM. It wasn't merged yet. We merged it a few weeks afterwards. So you can take a bunch of LXD servers. When you do the initial configuration through LXD init, it asks you whether you want to set up a cluster. You say yes, and then it pretty much works as usual. And all other systems, all they have got to do is say, I would like to join a cluster, enter the IP address, and now you've got a bigger and bigger and bigger LXD. CLI, API, everything works the same way. When you spawn new containers, they get balanced unless you tell us where you want them. So that was a big piece of work, but it's been working pretty well. We've been doing a bunch of bug fixes on it, obviously, but we've got people running tens of thousands of containers on clusters, and it works just fine. Other new feature was also something I presented at FOSDEM last year, LXD P2C, which is physical to container import tool. So it's a tool you run inside an existing system, and that sucks it up and sends it to LXD to run inside a container. So that tool was released as part of 3.0. We also did NVIDIA runtime integration. So that's passing through your CUDA libraries, your NVIDIA driver, and a bunch of that stuff for containers that want to do deep learning and AI type workloads. We added support for hot plug of Unix character and block devices. So effectively with that, you can say, hey, I want this serial port to go into that container. And even if it's not there when you start the container, when you plug it in, it's just going to detect the U event from udev and then pass it to the container. I did some more logic for storage volumes, effectively letting you copy storage volumes across the network as well. And we added a new device as a proxy device. It effectively lets you say that you want TCP port whatever on one of the host IP to be forwarded to whatever in the container. And it supports different modes. Like it will do IP tables, or it will do some fancier internal proxying we do. So you can even forward between UDP and TCP and between Unix socket and TCP, or we support a lot of weird combinations. All right, I'm gonna go pretty quick because as I said, we've done 10 releases, so I've got about a minute per release. The next one was a lot less busy. As it turns out, when you only spend a month on one instead of 3 months, there's less stuff. So we added backup support that lets you, through the API or CLI, export a container as a tarball, either just like a simple tarball of the root file system, or an optimized version, which includes like a binary blob of the storage driver you're using. So if you're using BurFS or ZFS, you can get that optimized blob, which makes it much faster to re-import, and also will save you space because it bundles like all the snapshot and all the metadata inside it. We've added automatic fan networking for clusters, so that's effectively an overlay network that exists on Ubuntu. If you enable clustering and you don't have a physical network that's shared between your containers, it will use that so that you get the same network and you don't have any weird issue with like a container being on one machine and another one being on another. Now going to 3.2, container migration between storage pools. So we did custom volumes 2 releases before that, but we still had a bit of a big gap where like containers could not be moved between 2 storage pools in your system. So finally fixed that. We've expanded what the proxy device can do by adding support at that point for Unix sockets, both abstract and normal file-based, UDP and port ranges. And we've also made it possible with like a single REST API call to join a node into a cluster, whereas before it was like 5 or 6 calls. Then next release, we've added a feature that lets a container pull images from its host. So if you're on LXD inside LXD, it can avoid going onto the network to download the image. It can just download it straight from the host. So it's a pretty convenient pass-through. We've added a new API to query networking details from the host. So that includes getting packet count, byte count, all that kind of stuff for any network device. It's pretty useful for clusters when you want to like look at a remote host in a way that's actually going to be compatible with what you want. We've added a small feature that people kept requesting, which is like a flag you can set on a container so that you can't delete it without first setting that flag, because people do typos and frankly don't like it so much when their production containers go away. So we did that. And on the proxy side, we added support for the HA proxy header protocol, and we added UID, GID mode control for Unix sockets, as well as supporting privilege dropping in the proxy device, which was needed if you are using a proxy device to forward X11 traffic. Because we can use that device not only for like normal web traffic or whatever, but you can also use it to forward your X server's sockets to the container so you can run graphical applications. And for that, you need the UID and GID to line up with your own user, so we need the privilege dropping for that. And we've added a built-in pprof server that you can turn on any address you want to then pull statistics or debug data out of LXD when it's running. All right. After that, so we improved on top of what we did for the automatic overlay feature for the bridge on clusters by also having a DNS forwarding protocol effectively that makes it so that the local, so we use DNS mask in the backend, and DNS mask will generate records for your containers. But if you're in a cluster, you want to see all of them, not just the ones that are on your machine. So we've added logic to effectively forward and replicate those across the cluster so that the DNS view is also consistent. We've added a new API that would let us pull all the data you need to list all your containers and all details in a single REST query instead of like 3 per container or something we had before. That made things massively faster, obviously. That's why we were working on getting effectively listing and interacting with 10,000 containers to take about 30 seconds instead of 5 or 6 minutes. So we got that to be pretty reasonable. And we've added file capabilities support in a bunch of different places that included when remapping the container, when unpacking images, like as some mentioned earlier in this room, file capabilities are getting pretty important for things like ping. And we were running into problems there. So we made sure that we used the feature that landed a few kernels ago to support unprivileged file capabilities, and that LXD itself knows how to read them, convert them, and write them properly as it remaps the containers. All right, other release. That one we improved our external authentication support. So we support something called macaroons, so they're fancy cookies, that's the name. that lets you do decentralized authentication and external authentication for LXD. So we've added support for multiple domains in there. We've added extra checks for security, and we've added, separately, we did some work to guarantee that the cluster upgrade is consistent. So effectively having the nodes that are not upgraded yet be aware that they need to upgrade now so they can do something about it instead of waiting until someone updates. Then, and I need to really start speaking fast now. Next release was a pretty big one. We added projects. So that's a way of grouping containers, images, and profiles and hiding them from each another. That's very convenient when you're working on a bunch of different things on a system, or if you've got a system shared with multiple people, you can use that feature to isolate who can see what, effectively, and grouping things together. We've added, done some more work on storage with snapshots. We've done the initial cgroup v2 support. Just initial, we don't do any of the fancy controllers yet. Added support for encrypted certificates because, yes, if someone stole your LXD cred, it'd be bad, so now we support password protection there. As Christian mentioned this morning, we added U-event injection for USB devices, and we improved some of our network handling to make it faster. Password another release, we added incremental container copies, so that lets you update a existing container to effectively run a backup host, and you can run background copies from one host to another and just keep that container up to date. We've also switched our default keys to elliptic curve, mostly because some architectures were stupidly slow with RSA. So EC was significantly faster to generate for what should be actually slightly better security. And I think that's the last one, I hope so. It is. We've added automated container snapshots recently, so you can give a cron type pattern on your container, and LXD will generate snapshots for you. We've added support for moving containers between projects. We've added support for replicating images within a cluster to make sure that you can't end up in a situation where you've got an image in the database, but it's nowhere near on disk because the node that had it is gone. And we've added support for better configuring what address you want clusters to use for the internal traffic and for public traffic. And that's it. That was a pretty busy year. I mean, we're a team of 3 people. I mean, 4 now, but it's been a busy year. And we expect next year to be just as busy, really. So that's, how much time do you still have?
2 minutes for questions.
All right. Anyone's got anything?
You mentioned backup of the containers. Do you have the container configuration in this backup or only the storage?
Backup right now, the way we do it is, so when you request a backup, it will create that optimized tarball effectively. It dumps it into one specific directory on the host that you could store onto whatever you want. There's no, just like images on disk, you can't tie them to a particular storage pool. Backups are the same way. But you can totally mount whatever you want on the backup directory, and then it will store that there. We might at some point make a way of actually tying that to a storage pool. It just gets tricky, and if you try to delete the storage pool, there's a bunch of corner cases that are a bit funny.
That's the mic there.
Thanks for some good work this year. Just a question, what's the status of Wayland and LXD containers?
Mm-hmm. So I've never actually, even though my laptop runs Wayland, I usually just forward X11 and let X Wayland do its thing. But the Chromebooks are Wayland. And clearly they've got it working. I'm not sure exactly what socket they need to pass. I think it actually depends on the compositor and the way that the API works for a particular shell, effectively. But it's clearly possible because that's what the Chromebooks are doing.
Hi, again, thank you for a nice presentation and all your work. There's been some changes with introducing the proxy service, and I'm wondering how does it behave with containers that, I mean, if it's just IP tables, nothing, how does it behave with containers migrating across the cluster, and does it actually do proper netting to wherever the container is within the cluster?
No, so that part it doesn't, reasonably often, people that run clusters will also have like an externally managed network, and they just manage it as part of the network rather than expecting LXC to be the gateway. We could do some very fancy things if we wanted, because that proxy, as I mentioned, like doesn't only do IP tables, it also does its own thing, where effectively it can attach to two namespaces and then does internal proxying between the two, which is very convenient because it means you can have a container that actually has no networking, and you bind a service on localhost in that container, and you can totally have the proxy to that. That works fine. In theory, we could change that thing to also proxy internally through API over the network, but it seems like a lot of work, and we've not really had a strong enough use case to spend a month trying to do that.
That's it.
All right, thank you.